Hi, everybody. This is the Unit 9A review. So, in this first section, we are simplifying rational expressions. So, first, we're going to start off with number one, and we only have monomials in our numerator and denominator. So, all we really need to do here is simplify our coefficients and then simplify our exponents. So, first, we have to think about 36 and 42. 36 is divisible by a lot of things: 2, 3, 12, 4, 9. And also 42 is also divisible by quite a few numbers. So I'm going to make a factor tree. 36, just the first thing that comes to my head is 6 times 6. And I can break both of those down to 3 times 2 and 3 times 2. So now I'm down to my prime factorization. I can do the same thing with 42, and just off the top of my head, that's 2 times 21 and 7 times 3. Because I just said, like, off the top of my head, I was just kind of picking numbers. It doesn't really matter what you decide to start to simplify by. Like, if I took 42 and said that's 6 times 7, I would break down my 6 to 3 and 2. And look, I have the same exact numbers down here as my prime factorization: 273, 273. Doesn't matter. Okay, so I want to see what they share. And they look like they both share a 3 and a 2. So that means that both of these are divisible by 6. 36 divided by 6 is 6. And 42 divided by 6 is 7. Now, I know I've simplified this completely because 6 and 7 are relatively prime, and they don't have anything in common with each other. X to the third power, we all know, means x times x times x. X to the second power is x times x. We all know that anything divided by itself is 1, so both of those are going to cancel out, and I'm just left with an x. I'm going to do something very similar in number 2. So let's see, 16 is 4 times 4, and 28 is 4 times 7. So if I cancel those 4s, I'm left with 4 and 7, and again, those are relatively prime. They don't share anything. Since 7 is a prime number, it's just 7 times 1. 4 is 4 times 1 or 2 times 2. And so those won't share a factor. I cannot simplify these A's and B's like I did with the X's because they're different variables. So you might have thought, is this a typo? It is not. I want you to know that this little cancel out trick only works when the variable's the same. A divided by B is not 1 because I don't know that A and B are the same number. They could be. I don't know. They're variables, and I'm not actually solving for them, so I will never know. Number 3 is going to need us to factor. Why? Because these aren't monomials. These are called binomials. There's 2 pieces. Binomial. So I think about 2r minus 4, and I know that 2 is 2 times 1, and I know that 4 is 2 times 2. So if I look at the greatest common factor here, the GCF, I see that both of these terms share a 2. So I'm going to factor out my 2, and I'm left with 1r minus 2. That just happens to be exactly what I have in the denominator. So it's not that my r's cancel out and my 2's cancel out. It's that this entire quantity, this entire expression, this entire binomial is going to cancel out. Just like x over x cancels out, r minus 2 over r minus 2 cancels out because those are the same. They will have the same value. So I'm just left with 2. Number 4 is kind of similar, except that I have a trinomial in my denominator. So for trinomials, I'm going to need to factor this using A, B, and C and making my table and split in the middle. So A is my number that's in front of my variable that's squared. So that's a 1. My A is 1, my B is negative 10, and my C is 25. So A times C is 25, and I'm looking for addition and subtraction with 25. That gives me 10. So we know 25 times 1, 26, 24, 5 times 5, 10, and 0. Is that it? Yes. So I'm looking for 10, and that's right here. It's under the plus column. That does not mean that the 5 and the 5 are both positive. It means they're the same sign. Since my b is a negative 10, that means both of these 5s will be negative. So I'm going to rewrite this. V squared, that's the same. Then minus 5v minus 5v, that technically is negative 10v plus 25. We know that v squared is v times v. 5v is 5v, obviously. We have a v in common. We are left with v minus 5. Here we have 5v and 5 times 5. Again, a 5 is in common. But if I just factored out a 5, I would be left with v plus 5. I want v minus 5. I want these to match. So in order to make that a v minus 5, this has got to be a minus as well. Think about distributive property. If I were to take this negative 5 and multiply it by v, that's negative 5v. That's what I had. What's negative 5 times negative 5? Positive 25. So I want this to be mathematically equivalent from step to step. Everything should be able to, anything that I factor out, I should be able to distribute back in. Okay, so since I have my parentheses, those two factors that match, I am going to write my final answer as v minus 5, the two things that I factored out, times these repeated parentheses, which is another v minus 5. So all that work, that was my denominator. So I'm going to go up here. This was my numerator that I started with. This is my denominator. So my numerator and one of these in the denominator are going to cancel out. So what am I left with in the numerator when I don't see anything? A 1. Technically, v minus 5 divided by v minus 5 is 1. Okay. Very similar down here. Number 5 is kind of a combination of 3 and 4. So in 4n minus 4, I know they're both divisible by 4. So this is 4 times 1 times n and 4 times 1. So 4 is in common. So I have 4n minus 1. I could say that 4 is also divisible by 2. Both of them are. But remember, this is the greatest common factor. And greatest, the G stands for greatest. So I want the biggest number that I can divide out of both of them. 24 is 6 times 4. Think about distributive property. 6 times n, 6n. 6 times negative 4, negative 24. I'll come back to this numerator because I have to do a little bit of work for it. But this denominator is a difference of squares. It's a binomial that's a quadratic. Both of these terms are squared. N squared is really n times n. And 1 squared, or 1 is really 1 times 1. So I'm going to make one of them n plus 1 and one of them n minus 1. And if you do your little multiplication box, you'll see how that works. N plus 1, n minus 1. N times n is n squared. This is positive n. This is negative n. This is negative 1. Those cancel. So I'm left with n squared minus 1. Exactly what I started with. Sorry, I didn't really make these boxes big enough. Okay, so let's look at my trinomial up in the numerator. I really have a 1 as the leading coefficient. So 1 times 4 is 4. I'm looking for adding and subtracting. We have 4 and 1, 2 and 2. This is 5, this is 3, this is 4, this is 0. I'm looking for 5. Again, it's under the plus column, but my b value is actually negative 5. So that means both the negative 4, or both the 4 and the 1 both have to be negative. So I'm going to split the middle. N squared minus 4n minus 1n plus 4. I have an n in common. In these first two parentheses, I have an n in common. I'm left with n minus 4. In the second parentheses, I don't have anything in common, so I'm going to make that a 1. But that would leave me with n plus 4. I need n minus 4. Okay, I'm reaching my limit on this video, so I will have to finish this one in the next one.